Hi everyone, welcome to my channel. Aditya here. So we'll continue our comprehensive course on AWS. We have covered up to synchronous execution of AWS Lambda. Now we'll continue asynchronous execution of AWS Lambda. Now what is asynchronous execution of AWS Lambda? How can you do that in Lambda? So we have so many other AWS services like SNS, Event Bridge, and S3, and many more for invoking Lambda in asynchronous way. So you can leverage these services to invoke Lambda in an asynchronous way. Okay, since this was asynchronously invoking Lambda, we will use an queue to store the incoming requests. Okay, what are the requests we are getting? We will use a queue to store the incoming requests. After that, Lambda will process that request from the queue. Now, we can configure the Lambda for retries up to 3 times, having exponential delay for x minutes. Here, the x should be the 2 minutes on each try instead of retrying multiple times simultaneously, which will cause the same failure again, right? So, for example, maybe it's some connection reset issue of a database or anything, which will take some time to recover. So, that's why we are introducing our lambda using this exponential delay so that each time we'll wait for the 2 minutes after each retry. Since we are using asynchronous way of execution, there will be a possibility of failures, and lambda will retry those failures as the configuration. So it will retry for 3 times exponentially, giving x amount of delay. And what happens after the failure? Right, still 3 times you tried the same request but it failed. Then to handle that situation only, we will configure a dead letter queue which holds all the failed requests for reprocessing. Otherwise, same request will be processed multiple times and CloudWatch logs stacked up with these duplicate execution logs. So we need to ensure our Lambda processing should be idempotent during retries. So what is the meaning of idempotent? Idempotent means you have to get the same result when you are executing some request. So then only we can say the process is idempotent. So we need to ensure that Lambda should be idempotent during retry. So that's why DLQ is required and configured with permissions, right? Because Lambda will able to write those failed requests into the dead letter queue, and in future it will use those information for reprocessing. So that's about asynchronous invocation. We can use SNS, Event Bridge, or S3 to invoke the Lambda, and we'll see what are the benefits here. Benefits of async invocations or executions. No need to wait for the response, right? So asynchronous invocation means you don't need to wait about response. You will submit some request and request will be processed by itself and you don't aware of what is happening there. The submission only your responsibility. And if you want to know the response, you can future use an another queue to send you response, right? In an asynchronous way. But in asynchronous, the meaning is you can send a request and after that you can do whatever you want, right? You can process remaining request instead of waiting for the response of the earlier request. So the processing time will be reduced. For example, the queue takes X amount of time to process. And if our application holds and we didn't get a result from the queue until the X amount of time, and we can say our application has X amount of delay, after completion only that request we have to move to the another request submission. So instead of that, if we use an asynchronous way, it will be easier. We don't need to wait for anything. You will get all the requests at a time. We don't need to wait for the response itself, and you can submit n number of requests, and the processing will be improved. For example, in an S3 bucket, I have uploaded a bunch of record, and each upload or each creation of objects, what will happen? That it will create an event, and it is going to trigger some notification service through Lambda. So what happens if we wait for response, right? The user get notification in very delayed manner, or there will be a delay in user notifications because the first object need to be sent notification to the user, and after receiving the response only the other user sent his request. Instead of that, if we use this asynchronous way, if we upload any thousands millions of files into S3, each one will be executed asynchronously without waiting for the request, and the source does not know about. Here, the source is S3. does not know about what is happening inside the Lambda. So Lambda will take care of the read, write, failures, those kind of things, and it will process the information and post to the SNS, and SNS will send to its end user. So that is the benefit of asynchronous invocation. Okay, now we will see how to asynchronously invoke Lambda through hands-on. We have this documentation from the AWS, how Lambda handles asynchronous invocations. So yeah, just look at this picture, right? You just send the events, and we have an event queue. As we discussed, this event queue will send request to Lambda, and these requests and responses, if you see, has been done inside the queue, not to the external users. So that's how asynchronously Lambda invokes. Now we will get a sample request to asynchronously invoke the Lambda from this documentation. So if you see here, if you use this request, we will get this response. So that's why I'm just copying this request for now. And now we'll go to AWS and do our hands-on. In AWS, first I'm going to open the Lambda. And since I have deleted my older Lambdas, so I have to create new one. So for that, I'm going to create a function here, and I'm going to use some blueprint, right? Blueprint, and we are going to use the hello world function. Let it be. It's Node.js. If you want Python, right? You can use the hello world Python also, fine. And you can give your name, function name. So I'm going to give the test Lambda. We're asking it to create a new role. We are not going to create any role, right? Create a new role with basic Lambda permissions. And this is our Lambda function, import JSON, and we have the Lambda handler, which will get event and context. And event is where we have our requests. So that's why it is called events. And finally, you are returning some value. Okay, that is your function. So I'm now creating this Lambda function. So the Lambda function creation will take some time. So let us wait for it and let it create. So the Lambda function has been created. This is our Lambda. Now we'll try to check this Lambda function once. This is the Lambda function. This is the code in it. So we have some values printing from the Lambda, which are coming from the event, and this is event key. We are returning it. So just we'll try to test it. So for testing, you need to create a new event. So I'm naming this new event as itself, test itself, and just private, and these are the key value pairs, and I'm saving it. That's it. So now we have test in place. Now we are going to test it. And you can able to see that you get a response of value, and in the logs you got the response ID and what are the values inside the events, and finally we have end of the request. Okay, now we'll try to invoke this Lambda asynchronously, right? Initially we have taken asynchronous, how to invoke Lambda asynchronously from this documentation, right? We are going to use this request and going to hit our test Lambda. For that, I'm going to use Cloud Shell. It's the AWS Cloud Shell itself. So this is a CLI environment to invoke any, to access any AWS function. So I am going to use this Cloud Shell for us. So yeah, it is loading. Let us wait for it. Yeah, the loading was completed. Now we'll try to invoke the Lambda using this Cloud Shell. So I'm pasting whatever I copied from that website. And here, if you see this command, it has the AWS Lambda invoke. That means we are invoking the Lambda. And what is the Lambda name? That is the function name, which is my function. So we need to change this to our function. That is test Lambda. And the invocation type is event. So this is a synchronous invocation. So it will store in the event queue. So that way the invocation type is event. Input we are giving. So right, what is the format of input we are giving? So that is CLI binary format raw in base64 out. And finally the payload is the actual input we are giving, that is key value. So what I'm going to do is I'm going to do key 1 value 1 and value 2 value 3. So you may wonder why I'm giving these values, because in our Lambda code we need this key 1 key 2 key 3 from the events, right? Otherwise the Lambda will fail. So that's why I have added those information and also changed the function name as test Lambda. Will one more time ensure that what is our function name. It is test Lambda, T capital and L capital, yes. So we're invoking, and invocation type is event. So I'm going to paste it. Okay, we'll see what is the response now. So once I executed this Lambda function, we got a response as status 202. And this response is not the actual result from the Lambda. This is just this CLA sent request to Lambda and Lambda responded, I received the information. That's it. What is happening inside the Lambda, we don't know. So we'll check that going to the Lambda monitor section, and in the below you have this option called this message called recent invocation, right? These many times I have invoked this Lambda after creating. So we have to take the latest invocation, right? This is the latest invocation. So if you observe this latest invocation from the CloudWatch logs, right, you can able to see we have value 1, value 2, value 3, what we have given. And yeah, this is the last request. So please ignore the above ones which I tried different times and got errors. So yeah, if you see this, right, at the end you have the latest invocation information, and you can able to see the start request ID and the values, that is value 1, value 2, value 3, and end, right, that is completed. So this is the logs when executing this Lambda, right? We'll try to execute one more time. We'll see. So it's executed successfully. We'll see whether this information comes here or not. So I'm going to resume it. Yeah, you can able to see, right, we have gotten one invocation, other invocation. So like that you can do an asynchronous invocation to a Lambda. Okay, and this is success scenario. We'll check the failure scenario also by manipulating the Lambda code. So go to the Lambda, and here they have given an raise exception thing. So I'm going to uncomment it and comment the actual return value. So now Lambda will raise an exception and Lambda will fail, right? So I'm deploying this change, and I'm going to test this change also now. Once deployed, right, we'll see here itself how it failed. So we have test. This is the response from the Lambda, right? Something went wrong, exception, something, blah blah blah. We'll see whether we will get this response, because if we get this response, that means Lambda is sending back the result, right? Okay, now we'll try to invoke the Lambda from the Cloud Shell. Since it's failing, we'll see what was the response. We are using the same thing, and you can able to see that you got a response as status 202. It's not the failure, because what is happening inside is asynchronously happening inside the Lambda. We'll see what is the invocation details here. So I'm going to refresh here these invocations where we have to refresh. So I'm going to refresh this page. We'll see what will be there in our recent invocation. This is the recent invocation. I'm opening it, and we'll go for the recent log at the down, and you can able to see, right, we're getting some exception in the log, but the failure is not there in the invocation time. So invocation is success, but internally it got failed. This is asynchronously invoking the Lambda, right? What we have discussed in the theory part, this event queue stores the request and we are going to process in Lambda. So in case of failures, we can configure retrace, and also we can configure that letter queue, right? So we'll see whether we can do that. So since we are doing an asynchronous invocation, right? So here, yeah, asynchronous invocation, here you have these things. So you have maximum age of event and how much time the event should be there, and also how many retrace we can do, and if any failures happen to those retrace, can I store in any dead letter queue for reprocessing. So we'll see. I am clicking on this edit, right, and here I can able to select the maximum number of retrace here. So I'm going to select 2 retrace. So after 2 retrace, right, we have to send this, we have to mark that particular request as failed, right? So instead of again reprocessing that again and again getting in failures, we can store that failed information in this SQS or SNS or SQS, that letter queue. So what should I do? I am planning to store in SQS, right? The queue, and we'll see here. I think I don't have any queue. We have to create a queue for that. So for that, I'm opening the queue. So SQS service in AWS, simple queuing service. And we need to create a queue now. Create queue. standard queue, and I am going to name it as test queue, and right, this and all I am going to leave as it is. I'm not changing anything, just I'm just creating a queue, just giving it a name. That's it. My queue name is test. That's it. So now I am taking this queue and going to Lambda, and we'll check whether this new queue is appearing in the drop down. Okay, so we'll select SNS, and after that we'll select this queue. We'll see whether any newly created queue coming up. No, it's not coming up. We will reload the Lambda itself. I'm giving 2 retries, then only send to the queue, and we're going to use SQS, and we have our test queue here. So I am declaring this test queue as a dead letter queue for our Lambda and saving. So here we got an error like the provided execution role does not have permissions to call send message on SQS. That means Lambda don't have permissions to write on SQS. So for that we need to change the role, the permissions, right? So I'm going to open this Lambda in another window, and here I'm going to add those permissions. So for that, go to configurations, permission section, and you have the execution role, right? This execution role is missing AWS SQS write operation. So if you see here, it has CloudWatch logs only the basic information, basic permissions, but we need to add that role also, or attach that policy also. So for that, I'm opening this, and here you have permission section. You can add your policies or add your permissions. So we're going to attach policy here itself, and I'm going to check for SQS, right? I'm going to add SQS full access policy for simplicity's sake, and adding permissions, right? So SQS full access policy also added for our Lambda rule, and we'll see whether now we can able to create uh, de create dead letter queue, like declare dead letter queue here, and we're selecting test itself, and we're going to click on save. Since we have given the permissions, now Lambda has been configured with the dead letter queue and also 2 retries. Now we'll try to hit now. So we have this failure request we are going to send now. We have this request which will fail inside the Lambda, we know that. So I'm asynchronously invoking Lambda. We're getting some response that is not the actual response. Now we'll see inside the Lambda and check whether how it's working. So I'm closing previous tabs which are not required for us, and I'm going to the Lambda and monitoring section. We'll see what happens in the recent invocation. I think this is the recent invocation, and it started at sometimes. Okay, we'll go inside. So it's showing something went wrong, right? We send that exception, and above also you have the same log, right? That means it is retrying 2 times. So this is one time, this is the second time. So it's tried retrying, and we'll see how stored in the SQS. So for that we need to open the SQS, and we will open our test queue which was configured as in that letter queue for our Lambda, and we'll try to do one thing. We'll try to receive or send requests. Okay, we'll poll for request. Any request came in here, and here you can able to see, right, a message has been added here after the retries. So that is key 1 value 1, key 2 value 2, key 3 value 3. That is the same we are sending. Okay, so like this we can set up a data letter queue for reprocessing. So this is the asynchronously invoking Lambda. So thanks for watching my videos, guys. If you like this video, like, share, and subscribe, and let me know in the comments if you need any new topics to include. And thanks for watching my videos. Bye.